Hello, my good friends. Derek Deschamps here for Internetworking Influencers, your source for free Cisco certification training for network engineers. Welcome to day 13 of our free CCNA 100-105 ICND1 training course. Internetworking Influencers CCNA 100-105 ICND1 training course is comprised of 13 videos, each focusing directly on a set of specific items on Cisco's official exam topic list. Today's episode will cover item 5.5, Perform Device Maintenance, including Cisco IOS upgrades and recovery using SCP, FTP, TFTP, and MD5 Verify, Password Recovery and Configuration Register, and File System Management. And item 5.6, use Cisco IOS tools to troubleshoot and resolve problems, including Ping and TRACEROUTE with extended option and Terminal Monitor. As a reminder, today's video has a set of free practice questions that are available on our website at internetworkinginfluencers.com that will help you brush up on the topics you learned today. The questions are a true representation of the types of questions you'll face on the actual exam, so be sure to check those out once we're done. Today we are going to start things off by looking at file system management. The Cisco IOS Integrated File System, or IFS, is a Cisco IOS feature that allows files and directories to be managed across multiple file systems. With IFS, each file system is assigned a prefix that is used to access the file system when using Cisco IOS commands. With IFS, file locations are specified using Uniform Resource Locators, or URLs. Each Cisco device has access to many different file systems. These file systems can be located on local storage devices, such as NVRAM and flash disks, or they can be located on remote devices, such as TFTP, FTP, or SCP servers. Each file system is assigned a prefix that can be used to access the file system when using Cisco IOS commands. For example, the file system that is located on NVRAM can be accessed using the prefix NVRAM:, while a file system located on a TFTP server can be accessed using the prefix TFTP:. File system prefixes are used with URLs to specify file locations. For example, if we wanted to copy a file from a TFTP server to a local flash disk, we would enter the command copy followed by the source URL. In this case, the URL for the file on the TFTP server, followed by the destination URL. In this case, disk0:. A similar syntax would be used to copy a file from an FTP server. Only this time, the source URL would include the username and password. In this case, the username is Derek and the password is let me in. A similar syntax would also be used to copy a file from an SCP server. Once again, the source URL would include both the username and password. Now that we know how the integrated file system works, let's take a look at how to use it. I'll begin by logging into a router that has been configured with the default settings and going into privileged exec mode by entering the command enable. Now, to view the file systems that are available on a device, we can enter the command show file systems. Here we can see a complete list of all file systems that are available on this device, and the prefixes that can be used to access them when using Cisco IOS commands. For example, here we can see that the NVRAM can be accessed by using the prefix NVRAM:. We can also see that this router has a flash disk installed, which can be accessed using the prefix disk0:. The asterisk on the left-hand side indicates that disk 0 is the default file system. This means if a command is entered and no prefix is specified, it will default to disk 0. Now, to view the files that are located on a file system, we can enter the command dir, followed by the file system's prefix. In this case, let's view the files that are located in the NVRAM by specifying the prefix NVRAM:. Here we can see the files that are located in the NVRAM, including the startup config. We can also see the total size of this file system and the number of bytes that are free. Now, to view the files that are located on disk 0, we can enter the command dir disk0:. Here we can see that disk 0 contains no files. We can also see the total size of this file system and the number of bytes that are free. Now, if we wanted to create a directory on a file system, we could enter the command mkdir, followed by the URL of the directory we want to create. In this case, let's create a directory on disk 0 named Cisco by entering the URL disk0:/Cisco. Now, if we enter the command dir disk0:, we can see that the directory has been created. Now, if we wanted to copy a file to this directory from a TFTP server, we could enter the command copy, followed by the source URL. In this case, TFTP:// 10.1.1.51/file1. Followed by the destination URL. In this case, disk0://Cisco/. Now, if we wanted to copy a file to this directory from an FTP server, we could enter the command copy followed by the source URL. In this case, ftp://Derek:"letmein" at 10.1.1.52/file2. Followed by the destination URL. In this case, disk0://Cisco/. Now, if we wanted to copy a file to this directory from an SCP server, we could enter the command copy followed by the source URL. In this case, scp://Derek:"letmein" at 10.1.1.53/file3. Followed by the destination URL. In this case, disk0://Cisco/. Now, if we enter the command dir disk0://Cisco, we can see that the files have been successfully copied. Now, if we wanted to delete a file, we could enter the command delete followed by the URL of the file we want to delete. In this case, let's delete all files in the Cisco directory by entering disk0://Cisco/**. Now, if we wanted to delete the Cisco directory, we could enter the command rmdir followed by the URL of the directory we want to delete. In this case, disk0://Cisco. Now, if we enter the command dir disk0:/, we can see that the 3 files and the Cisco directory have been deleted. The next topic we will look at today is Cisco IOS upgrades. The configuration register is a 4-digit hexadecimal number that is used to set various boot parameters. The configuration register always begins with the prefix 0x. This indicates that the configuration register is expressed in hexadecimal. When the configuration register is converted to binary, each hexadecimal digit represents 4 bits. The 4 bits associated with the last hexadecimal digit make up the boot field. The boot field is used to specify which Cisco IOS image to load during the boot process. The default value for the configuration register is 0x2102. When the configuration register is set to 0x2102, the device will load the Cisco IOS image specified by the boot system command. If an image is not found, the device will load the first image in the default flash file system. If an image is still not found, the device will boot into raw monitor mode. For example, with this device, the boot system command has been used to specify the location of the Cisco IOS image. The config register command has also been used to set the configuration register to 0x2102. Now when the device boots, it will load the Cisco IOS image that is specified by the boot system command. If the image is not found, the device will load the first image in the default flash file system. If an image is still not found, the device will boot into raw monitor mode. Now that we know how a device chooses which Cisco IOS image to load, let's take a look at the upgrade process. I'll begin by logging into a router that has pre-configured interfaces and going into privileged exec mode by entering the command enable. Now before starting the upgrade process, you must first download the Cisco IOS image from the cisco.com website and place it somewhere it can be accessed, such as a TFTP, FTP, or SCP server. In this case, I've already downloaded the image and placed it on a TFTP server. Now the first step in the upgrade process is to copy the image from the TFTP server to a local file system. To do this, we enter the command copy followed by the source URL. In this case, the URL for the image on the TFTP server. Followed by the destination URL for the local file system. The local file system you choose should be of type disk or flash. In this case, let's copy the image to the disk 0: file system. The next step is to verify the integrity of the image to ensure the image has not been corrupted. To do this, we enter the command verify/MD5. followed by the URL where the image is located. Followed by the MD5 hash value that was listed on the Cisco.com website when the image was downloaded. The router will now compute the MD5 hash value for the image and compare it to the value we provided. If the two hash values are identical, the integrity of the image will be verified. Here we can see that the two hash values are identical and that the integrity of the image has been verified. Now that our image has been copied to the local file system and verified, we are ready to configure the router to load the image. To do this, we must first go into global configuration mode by entering the command configure terminal. The next step is to configure the router to load the image during the boot process. To do this, we enter the command boot system followed by the URL where the image is located. We now need to set the configuration register to 0x2102. To do this, we enter the command config register 0x2102. Now that this command has been entered, when the router boots, it will load the image specified by the boot system command. We can now exit out of global configuration mode by typing exit. Next, we need to save the configuration by entering the command copy running config startup config. Now to complete the upgrade, we reload the router by entering the command reload. Alright, so now that the router has been reloaded, we can verify the upgrade by entering the command show version. Here we can see that the router is using the upgraded Cisco IOS. We can also see the location of the Cisco IOS image. And lastly, we can see the configuration register has been set to 0x2102. The next topic we will look at today is password recovery. The first step to recovering a password on a Cisco device is to boot the device into raw monitor mode. To do this, we can either remove the flash before powering on the device and reinsert the flash once in raw monitor mode, or we can press the break key sequence during the boot process. The second step is to set the configuration register to 0x2142. This causes the device to ignore the startup configuration when booting. To do this, we enter the command config 0x2142. It is important to note that the syntax of this command is different from the one used in global configuration mode. The third step is to power cycle the device and bypass the initial configuration dialog. To bypass the initial configuration dialog, we simply answer no when prompted. The fourth step is to log into the device and enter privileged exec mode. To enter privileged exec mode, we enter the command enable. Since the startup configuration was ignored while booting, this will not require a password. The fifth step is to load the startup configuration. To do this, we enter the command copy startup config running config. Once this command has been entered, the device's startup configuration will be loaded. However, we will not need to know the passwords because we are already in privileged exec mode. The sixth step is to reset the password. To do this, we must first go into global configuration mode by entering the command configure terminal. In this example, the enable secret password has then been reset using the enable secret command. The seventh step is to set the configuration register back to 0x2102. To do this, we enter the command config register 0x2102. We can then exit out of global configuration mode by typing exit. The eighth and final step is to save the changes. To do this, we enter the command copy running config startup config. The last topic we will look at today is Cisco iOS tools. The ping command is used to test connectivity to the specified destination. For example, with this network, if we were logged into router 1 and wanted to test connectivity to router 4, we could use the ping command, with router 4's IP address as the destination address. Once this command was entered, router 1 would send an ICMP echo request to router 4. Once router 4 receives the ICMP echo request, it would reply back with an ICMP echo reply. When router 1 receives the ICMP echo reply, the attempt would be considered a success, and connectivity would be confirmed. If router 1 did not receive a reply before a default of 2 seconds have passed, router 4 would be considered unreachable. By default, this process is repeated 5 times. The displayed results include the success rate, as well as the average round-trip time in milliseconds. The TRACEROUTE command is used to determine the path a packet will take to reach the specified destination. For example, with this network, the TRACEROUTE command has been used on router 1 to determine the path a packet will take to reach router 4. To identify the first hop in the path, router 1 would send 3 packets to router 4, destined for an invalid port number with a TTL of 1. The TTL indicates the distance in hops that the packet can travel before being discarded. Before a router forwards a packet, it decrements the TTL. If the TTL is equal to 0, it discards the packet. This means the 3 packets with a TTL of 1 would be discarded by the first hop, in this case, router 2. Router 2 would then send 3 ICMP time exceeded messages back to router 1 to let router 1 know that the packets had been discarded. The source address of the ICMP time exceeded messages would identify router 2 as the first hop. To identify the second hop in the path, router 1 would send 3 packets to router 4, destined for an invalid port number with a TTL of 2. The 3 packets with a TTL of 2 would be discarded by the second hop, in this case, router 3. Router 3 would then send 3 ICMP time exceeded messages back to router 1 to let router 1 know that the packets had been discarded. The source address of the ICMP time exceeded messages would identify router 3 as the second hop. To identify the third hop in the path, router 1 would send 3 packets to router 4, destined for an invalid port number with a TTL of 3. This time, the packets would reach router 4. Since the packets were sent to an invalid port number, router 4 would discard the packets. Router 4 would then send 3 ICMP port unreachable messages back to router 1 to let router 1 know that the packets had been discarded. The source address of the ICMP port unreachable messages would identify router 4 as the final destination. The terminal monitor command is used to enable the display of debug and system messages for the current terminal session. The terminal monitor command can be used during telnet or SSH sessions only. The terminal monitor command can be disabled using the terminal no monitor command. For example, on this device, the terminal monitor command was used to enable the display of debug and system messages for the current terminal session. Once this command was entered, several system messages were displayed as they were being generated. The terminal no monitor command was then used to prevent further debug and system messages from being displayed. It is important to note that the terminal monitor command applies to the current telnet or SSH session only. This means the command will automatically be disabled when the session is terminated. Now that we know how these Cisco IOS tools work, let's take a look at how to use them. I'll begin by logging into a router that has pre-configured interfaces and going into privileged exec mode by entering the command enable. Now, if we wanted to test connectivity to a specific destination, we could enter the command ping followed by the destination address. In this case, let's test connectivity to 10.4.4.4. Here we can see that 5 ICMP echo requests have been sent to 10.4.4.4. We can also see the result of each attempt. Each exclamation point indicates a successful attempt, while a period indicates a failure. In this case, all 5 attempts were successful. We can also see the success rate, in this case 100%, as well as the average round-trip time in milliseconds. By default, the ping command will use the IP address of the outgoing interface as the source address. If we wanted to use a different source address, we could perform an extended ping. To do this, we enter the command ping without specifying a destination address. We are now prompted for the protocol. In this case, we will use the default of IP by hitting enter. We are now prompted for the target IP address. In this case, let's once again use 10.4.4.4. We are now prompted for the repeat count. In this case, we will use the default of 5 by hitting enter. We are now prompted for the datagram size. In this case, we will use the default of 100 bytes by hitting enter. We are now prompted for the timeout in seconds. In this case, we will use the default of 2 by hitting enter. We are now asked if we want to enter extended commands. In this case, we will enter Y for yes. We are now prompted to specify the source address or interface. In this case, let's specify a source address of 10.0.0.1. Since the source address was the only extended command option we wish to change, we can now simply hit enter for the remaining prompts. Here we can see that 5 ICMP echo requests have been sent to 10.4.4.4. We can also see that the packets were sent with a source address of 10.0.0.1. And lastly, we can see that the success rate was 100%. Now, if we wanted to determine the path a packet would take to reach a specific destination, we could enter the command TRACEROUTE followed by the destination address. In this case, let's determine the path a packet would take to reach 10.4.4.4. Here we can see that the first hop in the path has been identified as 10.2.2.2. Listed to the right of the IP address is the round-trip response time to this device in milliseconds. Next, we can see the second hop in the path has been identified as 10.3.3.3. And lastly, we can see that the third hop in the path has been identified as the final destination 10.4.4.4. By default, the traceroute command will use the IP address of the outgoing interface as the source address. If we wanted to use a different source address, we could perform an extended traceroute. To do this, we enter the command traceroute without specifying a destination address. We are now prompted for the protocol. In this case, we will use the default of IP by hitting enter. We are now prompted for the target IP address. In this case, let's once again use 10.4.4.4. We are now prompted for the source address. In this case, let's use a source address of 10.0.0.1. Since the source address was the only extended command option we wish to change, we can now simply hit enter to the remaining prompts. Here we can see that in this case, the path has remained the same when using a different source address. The last Cisco IOS tool we will look at today is the terminal monitor command. The terminal monitor command can only be used during a telnet or SSH session. Since this is currently a console session, let's connect to a different router using telnet before we begin. We will now go into privileged exec mode by entering the command enable. Now, before using the terminal monitor command, let's first verify the default system message logging configuration. To do this, we enter the command show logging. Here we can see that by default, monitor logging is set to a severity level of debugging. This means by default, system messages up to a severity level of debugging will be displayed when using the terminal monitor command. As we learned in the last episode, this setting can be changed using the logging monitor command. However, in this case, we will simply use the default settings. Now that we've verified the default configuration, let's enable the display of debug and system messages for the current terminal session by entering the command terminal monitor. Now that this command has been entered, debug and system messages will be displayed as they are being generated. So now let's generate some debug messages to see how this works. Debugging is used to generate detailed log messages for troubleshooting purposes. It's important to note that debugging can cause significant load on a device's CPU. Therefore, it should only be used with extreme caution. To enable debugging, we enter the command debug, followed by one of many different options. In this case, let's enable debugging for ICMP transactions by entering the option IP ICMP. Now, if we enter the command ping 10.4.4.4, we can see that debug messages are now being displayed for ICMP transactions. These debug messages are being generated by the debug command and are being displayed by the terminal monitor command. Now, to disable debugging, we can enter the command no debug all. And lastly, if we want to prevent debug and system messages from being displayed during the current terminal session, we can enter the command terminal no monitor. Now that this command has been entered, debug and system messages will no longer be displayed. And that brings us to the end of day 13, which was the final day of Internetworking Influencers CCNA 100-105 ICND1 training course. Don't forget to complete the free practice questions for today's material, which can be found on our website at internetworkinginfluencers.com. The free questions will help highlight the key points that Cisco will expect you to know for the exam. Also, if you enjoy our free training and would like to show your support, please check out our Patreon page. We offer numerous perks to our supporters, ranging from additional practice questions and detailed study notes for each video, to direct access to our instructors to answer any questions you might have. I'll be back next time for day 1 of our all-new CCNA 200-301 training course. The new course will cover all topics on the new CCNA 200-301 exam. I'm Derek Deschamps for Internetworking Influencers. Thanks for watching.